Today we need to generate the optimal code for the given SDT. SDT is S tends to ID, ID is equal to E tends to E plus E1 plus E2 and E tends to ID. For that we need to generate optimal code, and we are supposing here new temp is a function that return the name of the new temporary variable on every call, and we are assuming T is a temp variable, and we are assuming the string is x tends to y plus z. So what will be the optimal code for this? As it is given s id is equal to e, so we are taking id equal to e. Then next is e tends to e1 plus e2, so we will take this one e1 plus e2, as we need to take x is equal to y plus z. So this will be x equal to, and e1 tends to id, so id that will be y, and e2 also tends to id, that will be z. So x is equal to y plus z. Now we will make optimal code for this. So what it will be, as we are saying that we are taking new temp is a function that returns name of the new temporary variable, and we are supposing T is the temporary variables on every call. So here we can see simply E2 for E2 or for E1 we can take T is equal to new temp function, that is we are taking T1, and because this is y, so we can say T1 is equal to y, or we can say E dot place is equal to T, so we can say E1 or we can say E, whatever. E dot place is equal to T1. In the similar way we will work here. We will generate the new temp function that returns the name of the new temporary variable on every call. This is one call, this is second call. So we are taking T is equal to new temp, that is T2 to differentiate it, because we have taken here T1, so we are taking here T2. So this is Z, so T2 is equal to Z, or we can say E dot place is equal to, sorry, not T1, T2 is equal to T2. So now we will go further. So for this we will take again new variable T is equal to new temp function we will create. For this it will create a new variable, that is T3. So we can say T3 is equal to T1 plus T2, because here we have taken T1, here we have taken T2. So T1 plus T2, T1 plus T2. And here for this we can say it will generate x, because our ID is x, is equal to, because whatever we are having here T3 is equal to T1 plus T2, so we are equating it here equal to x is equal to, so we are saying x is equal to E dot place is equal to T3, because we are writing x is equal to y plus z, and y plus z are T1 plus T2, so this x will be T3. So x is equal to E dot place is equal to T3. So suppose if we have four options, suppose if we have four options in a question, so what will be the answer? We will see here what is the optimal code. If suppose option 1 is equal to x is equal to T1, and T1 is equal to y plus z, and B option is equal to T1 is equal to y, T2 is equal to z, and T3 is equal to T1 plus T2, and x is equal to T3. The third option is suppose T1 is equal to y, comma t2 is equal to t1 plus z and x is equal to t2, and D option x is equal to 5 plus z. So which one be the correct answer? So we can say, we can start from here. No temporary variable is here, so it cannot be the answer. Or we can say when no temporary variable is given, then this will be the answer, because here we are taking every time temporary variable. And here in option C, what we are having only left hand side, or we can say even only we have temp variable, but E2 we don't have temp variable. In that case, this answer will be the true. And in the similar way, E tends to ID. Here it is given x is equal to t1 and t1 is equal to y plus z. When E tends to ID, that option is not given, then this is the correct answer. But as according to our question, everything is given here. So t1 is equal to y is here, t2 is equal to z is here, t3 is equal to t1 plus t2 here, and x is equal to t3 is here. So according to this question, the answer will be B. Otherwise, if no temp variable is given, then answer is D. If only left hand side temp variable is given, then answer is C. And here when E tends to ID is not given, then answer will be A. But according to our question, this answer will be the correct answer. So in that way, we can generate the optimal code for any given SDT.